Hello, hi, and welcome to another episode of the Inquisitive Universe. My name is Jeffrey once more, and this is a channel where we talk everything about phones. It's all about phones. Yeah, that's all we do. We could branch out later on, but right now it's all we care about: smartphones. So in today's episode, I want to talk about different types of data that you can find on a smartphone, as well as the different type of storage facilities that holds these different types of data. So basically speaking, there is two types of data on a smartphone. You've got temporary data and you've got permanent data. Obviously, these data types are going to have like different storage facilities that would hold them, either temporarily for temporary data or permanently for permanent data. So let's get straight into temporary data now. So what is temporary data? It's in the name. It's temporary. It's only designed to last for a short period of time. So temporary data on your smartphone are those like bits of data that are not designed to last around for a very long time. You could also say that temporary data is that type of data that the CPU needs to carry out its functions in order to like keep your phone running smoothly. Now, a very good example of temporary data is rather our app processes, for example. Then there's also cache, but cache is a special case. I'll get to that in a minute. So let's look at app processes, for example. Let's say you want to load up Facebook, for example, or Twitter, right? Now, your CPU cores are going to need to locate the app, because the app has got an APK as well as other like bits of data that it stores. It's going to have to locate it in your internal storage. Now it's going to get that storage and it's going to fetch it and like bring it up. But the CPU doesn't really have like enough memory of its own. Yes, the CPU has got like little bits of memory called cache in itself, that's CACHE, but those are like mostly in kilobytes. With I think L3, CPU cache is L1, L2, L3, but L3 is basically 3 megabytes for some mid-range CPUs and stuff, as if we're lucky. I'm just speculating now at this point. So the CPU cache isn't a lot to hold that amount of data. So there's going to be a little problem here because the internal memory is slower than the CPU. So if the CPU doesn't get data fast enough from the internal memory, the CPU is just going to be idling away when whilst the internal storage is trying to get like data out to the CPU. So what happens is that there is a special type of memory that sits in between the CPU cores and the internal storage or the internal memory, and that storage is called RAM. So whenever the CPU fetches data now from the internal storage, it's going to take the important bits of the app that is running and then it's going to keep them in the RAM. Random access memory is going to keep it there. So RAM is much faster than internal memory, much faster. Not as fast as the CPUs do, but it's much faster and it's closer to the CPU. So there is really not the problem of the CPU idling away, the phone slowing down whilst the internal storage is trying to sort itself out. No such problem. RAM is like pretty fast. So whenever the CPU takes an app from the internal storage, keeps it in RAM and starts like processing the app and making sure that you are scrolling through your feed, you are giving out likes, you're giving out hearts, you're posting pictures, the data is there on the RAM, the app process is there on the RAM to make sure that the CPU gets the data it needs to process that very app. So the data that is stored in the RAM is what is called an app process. So app processes are temporary data because when you're done with the app and you swipe the app away, the operating system is going to have to say, all right, this app is no longer in use, yeah, get out of the RAM, delete. But before it deletes the app out of the RAM space, it's going to save the important bits of data, like stuff you viewed, the pictures you've liked, and all those stuff. It's going to save those little bits of data and then compress it to a very tiny small file. Sometimes it's no bigger than 2 kilobytes. Sometimes it's no bigger than 2 kilobytes, 10 kilobytes, and so on and so forth. Sometimes it could be as much as 5 megabytes, but there you have it. It's just like little bits of data about like your session, your last session with the app. So when it's done with that, it's going to then save it and then push it to the internal storage. That data that contains the bits and pieces of your last session, what you did with the app, all those other little stuff, they are called cache. Like I said, app processes, when you're done with the app process and you kick it out, this operating system is going to save bits and pieces of your last session and then it's going to save it to the internal storage. So the reason why it saves this cache so that when you come back into the app, you're going to pick up right where you left off. So that's what app processes. So you've got app processes now, which are data that runs in the RAM, which are temporary. That when you get out of the app, it's kicked out, and then you've got cache, which gotten from the app processes that were running before, and then saved to make sure that you pick up right off from where you left off. Now, cache is a very curious case because it's temporary data that can be saved permanently, right? So if you cache is not necessarily a bad thing, right? Because cache helps your phone keep track of, like what you have been doing so far, and then make sure that whenever you get back into the app or into your game or whatever, you pick up right where you left off. Like, that's it. But the problem with cache is that your CPU is very fast and it's going to be saving, like, bits and pieces, bits and pieces, bits and pieces. Cache could add up, aggregate, and become a problem. There are some times where in a week I clear about 5 gigs, right? 5 gigs of cache data. So if you let like cache like pile up, it's going to aggregate and it's going to seriously limit your smartphone storage memory. The storage space that you could use to save other stuff will just be occupied by RAM. So you should, like, from time to time go through your storage and then get rid of, like, all those annoying cache. The only problem is that fighting with cache is mostly losing battle, because as soon as you delete it, your smartphone is your CPUs or your smartphone, your operating system is simply going to create more cache and then put it there. So it's kind of like you have to do your due diligence to make sure that, like, necessary cache, or rather all unnecessary cache are booted out of your smartphone. So with that out of the way, let's look at permanent data. Permanent data are data that are meant to be stored permanently. Now, these are like data that actually belongs to the user. Now, whilst temporary data helps the CPU carry out its functions, permanent data belongs to the user. Your apps, your games, your videos, your photos. I think some of us, like, we have like huge storage spaces now, 128 gig, 256 gig, and some people like there are people I know that if I want movies, it's going to be there on their phone. Like, ooh, they've got entire series, The Witcher season 1 and 2. It's all in there. The Hitman, like even the ones that love Z-World and telenovelas, there's so much data on their phone, and I wonder, how do these people manage their spaces? So permanent data is data that is meant to be stored permanently, at least until the user decides to, like, let it go or kick it out. So permanent data is usually stored on either the internal storage, or, if the user so chooses, an SD card. So basically, like I said, you've got temporary data, you've got permanent data. Temporary data is stored in the RAM. Permanent data is stored on internal storage or on the SD card. So there is that. I wanted to make this video because I needed to do an introduction to, like, the whole, because I'm starting a series now, like the whole smartphone storage series, because I want to do videos on smartphone storage itself, which I have already done. I want to do a video on the RAM, I want to do a video on ZRAM, I want to do a video on virtual memory, and I want to do a video on internal storage and SD cards. I don't know if I should do one on HDD and SSDs, because that's kind of like beyond our scope, but then again, I guess I have already spent quite a bit of time on this video. Please make sure to like, make sure to subscribe, and if you can, if it's not too much of a bother, please share this video with your friends and families and anybody that you know probably needs information like this. It's just me sitting here and then, like, trying to, like, let you guys know this stuff as I understand them, as I think it would be easy for, like, lots of people to understand. So that's basically it. My name is Jeffrey and I will be signing off.